guten Tag, здравствуйте. The dock is in, and today what we're going to be doing is we are going to be taking these pennies right here, and we're going to be melting the zinc that's in them, using nothing more than this stove right here. Sorry about that, it's a little shaky, but using nothing more than this stove right here, and it's already on, as you can see. It's heating up, it's getting warm, but I don't want to put these pennies on yet until we get this heated up to temperature. So basically then while we wait for this to heat up, I'm going to tell you, zinc has a melting point of roughly, I think, about 400 to 600 degrees Celsius, which in Fahrenheit, I have no idea what that is. But anyway, so one of these pennies, basically what a penny is it's copper coating around a zinc core. Basically, in a little bit of history about this, in 1986, the U.S. Mint was producing solid copper pennies. But because the penny was losing value, what happened was that Congress decided, okay, the penny is being made, like we're making more, or we're making pennies out of something way more than they're worth. So what they decided to do was they decided to make them out of zinc and then just coat them in copper. And so what we're going to do is we're just trying to get the zinc out of here for later experiments. Now, and we're going to do so only on a stovetop. Now, stovetops obviously are quite hot. They can get at least to 100 degrees Celsius because we know they can boil water. We know that they can melt pewter, which is another type of metal compound. And the way I know that is because I've tried it with one of these keychains. Let me go grab one. One of these little keychains. If you've seen the new Jumanji movie, you may have gotten one of these. They were giving these things away. See, Jumanji. These are made out of pewter, and these are actually my brother's, but I had two of these, and one of them is on my keychain, and the other is melted down, so I'm not going to show that to you today. Maybe in a later episode I'll show you. But today we're just going to be melting pennies today for the zinc. And just so you know, pennies today are nearly worthless. The U.S. Mint is basically losing money for every penny they make. They're basically losing 0.07 of a cent every single time they make one of these things. So they're basically useless or worthless now. They're actually considering taking the penny out of U.S. currency. So I think we're getting pretty toasty now. Let me see here if you can see the wave of heat. Or wait, let me do it this way. Should be able to see the heat coming off from that and making sure that it didn't melt my little pop socket on the back. So yeah, I think we are ready to put our pennies on. So yeah, let's just hold it right on that. What you're probably hearing, that little popping, is that's an old candle holder. So yeah, so that's probably just the old wax. Let me actually turn the fan on. So yeah, now we just wait, and those pennies will slowly begin to melt, or at least they should. I don't know. Hopefully this thing doesn't melt that I have them on. Okay, it looks like it is, so I'm actually gonna put this down for just a second. One moment. Alright, so quick update, guys. Sorry about that. I was thinking that this thing was gonna melt, and it probably might, so I'm not sure if it is or is not, but as you can see the pennies, if you can kind of see that, if I can get it close enough without melting my phone case. As you notice, look at Lincoln, this Lincoln right here, right there. As you'll notice, he is getting a little pale, and the reason being is because the copper coating on these pennies is very, very thin. It is extremely thin. Let me just poke at him. Okay, he's not that toasty yet, but still, this is actually quite hot, and this thing is all the way up at full heat, so, yeah, is it? Oh dear, I might need to move this. Oh crap. One moment. I'm going to put this right here. Flip it around. Alright, so quick update, guys. If you notice, that bottom penny right there is becoming very, very pale. If I can get my finger close enough without melting it. Yeah, so that's showing it's nearing its liquefaction point. It is getting very toasty, if you can see. Sorry about that. Oh, look at that penny right there. It's beginning to warp. So's that one right there. So yeah, basically this is not considered defacing US currency. These things are basically worthless now. Meaning the zinc. Now copper on the other hand has a much higher melting point, so what you're seeing is basically the shell is copper, but the inside zinc core is becoming liquefied. So if I just get this tap right, oh crap. If I give that a little tap right there, pull that up, you would see that, ah crap, get off of my pliers. As you can see, the zinc is, ah crap, I can't pull both things. Okay, one moment. Now, what you are looking at right there, those little silvery beads right here and here, that's the zinc. So what I've been doing is I've just been kind of squeezing it out. Sort of. There we go. So, just kind of squeezing it out almost like a little pimple. Okay, that is really getting hot. Let me see if I can turn the light off. So yeah, as you can see, that thing is glowing a lot. And even my phone is starting to get really, really toasty. Let me actually put the light back on. Okay. Yeah, now if you've seen my trailer, you're probably wondering where are all the explosions. I will get to that soon. I just don't have the equipment yet. So I wanted to make this zinc for you because I'm going to show you how we're going to use this homemade zinc, or yeah, this homemade zinc in a later episode where we're going to mix it with other chemicals and create explosions with those. Stay right there. Okay. So yeah, sorry if this isn't your cup of tea. Believe me, these episodes will get better. Just right now, they are slightly lacking due to the fact that I am slightly under certain... Okay, let me actually take this off for a second. So yeah, basically, we're gonna keep this on here and... Oh, that's hardened already. Let's just get that right back to our little heated zone. While waiting for that to melt. Look at my little doggy. She's sleeping right now. Sorry if this is shaky. And okay, my other one's in her little house, but look. Oh, she heard something. And she's probably gonna go right back to sleep. This has nothing to do with science, I'm just really bored and waiting for the zinc to melt. Let's see if it is getting any. Alright, quick update, guys. I think our zinc is pretty much almost completely liquefied. I'm going to give it like about 5 more minutes, and then we're going to throw it into this little thing of water over here. Let me actually turn the main light on. Right there. There we go. Into this little thing of water right there. So, I'll let you guys just watch right here. I don't have a stand to keep this on, so you guys can't let me know if that and plus goes out there. So. Alright, so yeah, that's pretty much melted now. So what I'm going to do is I'm going to just try with the one hand I'm holding my phone with, and then the other hand I'm trying to... Let me actually put my phone in my left hand and grab this in the other. Okay, right here, right here, right here, and we just go. That was cool, if you guys could see it. All that right there, that is zinc. And remember when I was saying how toasty and warm it was? Actually, just put that back just in case there is any. Oh, well, there goes that. Alright, anyway, so remember when I was saying how hot that was? Well, watch this. I threw it in the water, and I can just, right now, pick it up with my bare hands, and look, it's even taking the shape of my little dish here. Now I can even hold my dish, no problem at all. This is it. Now, all of this right here, this is all from zinc, right here. This is all zinc. And all those little other things are probably just copper. It's probably just the unmelted copper and stuff. So yeah, ah crap. Yeah, so anyway, that's it. That's probably it for this video. Actually, wait. You know what? Let's actually try another metal. Let's try some aluminium next. I mean, the stove is still quite hot. And so, yeah, let's try another metal. This is zinc, so we all obviously know zinc melts on the stove. Let's try, I think I have some pewter. One moment, I'll be right back. Alright, so this is a whole bunch of metal and stuff. This is the aluminium we're going to try and melt. Probably a smaller bit of that. But, yeah, I've got a ton of little bits of scrap metal from batteries and all kinds of things. I even have some batteries in here. I even think this is some alcohol that was apparently evaporated alcohol that fused itself onto a plastic container I had it in. So yeah, that happened. Oh, focus in. Sorry, there's my thumb in the way. This is an old guitar string, probably stainless steel. So we're probably not going to be able to melt that on the stove. Oh, that's another stainless steel ring right there. Where's the pewter? I think this is it, isn't it? Nope, that's an old battery. Let's see here. There it is, I think. Nope, that's not it. Let's see here, where is the pewter? There it is. Right there. Yeah. Right here is the old Jumanji thing I was talking about. It looks quite different from when its original form, which was, it was a rhino, I think, or was it yeah, it was a rhino at first. So yeah, that was it originally, and now that's it now. So yeah, let's actually, I'm going to show you, this is pewter right here. Toss that into my little thing there, and I'm going to put this on the stove, and I'm going to show you how it melts. There's our pile of zinc we just made. Yeah, that's actually a good amount of zinc. Oh, and this actually right here was an old penny I melted on a campfire. Melted that on a campfire, so. And this is the aluminum foil we're going to try after that, so one moment. Actually, I don't even think we have to wait a moment. Right, fudge. There we go. Grab you, put you right there on the stove, and then there goes the water. Now, pewter has a much lower melting point, about 200 degrees Celsius, much lower melting point than zinc. So this thing is going to start, watch this little like fishtail at the end right there. That thing's just going to start drooping and eventually going to drop very soon, because this thing hasn't lost any heat. Uh-oh. I almost thought I heard a crack on the camera lens, because this thing is quite hot. Don't want that to happen. So I like my iPhone. It's so nice. Yeah, it's getting really toasty. It's getting really toasty. Yeah, nothing so far, but it's getting there. Because the thing is what you have to do with metals, and with anything really. Like with snow, that's the reason why like moving water doesn't freeze, even though it's like, you know, like -3 outside, and that's in Celsius, by the way. Like if it's even below freezing and your like river in your backyard hasn't frozen, it's because it's flowing in in order for it to reach that freezing point, both the substance and the air temperature around it have to reach its freezing point. Same thing with metal. Both the metal and the environment around it have to reach the melting point, which in pewter's case would be about 200 degrees Celsius. Twice the melting point boiling point of water. Well, I think our fishtail's starting to droop. Yeah, there it goes, Yep, there it goes. See, there's a little crack right there. If you can see if I can actually just zoom in, because I can't put my camera a bit closer, else the lens is going to crack. But yeah, this thing, yep, there goes the fishtail. So if I poked at this with a little wires, yep, there you go, right there. And right there is a little bit of molten pewter. We're just gonna watch this like just melt and become like not just a puddle, but like, yeah, like a little puddle of pewter. And I have the fan on just in case like any water or any other things in the little old candle holder begin to like vaporize and stuff. I don't want that in the air in my kitchen, so yeah, let me actually poke at this, because that shell probably is a little bit of resistance. Yeah. And right there is, oh, where'd it land? Oh, there it is, right in there. I'm gonna get that in a moment. Yeah, 1 moment. So yeah, right there, if you can see, okay, if I can stop shaking so much. Watch that little thing there. See? Yeah, that's completely liquid now. So now let's go give it a bath. As you know, I can just pick this up without any problem. The reason being is because chemically what happens when it just like is dropped into water, something much colder than it, what's going to happen is that the metal will instantly go to that temperature because metal has specific heat. That's a specific heat thing. With specific heat, it's has to deal with temperature of the air or environment around a substance and the temperature that the substance itself is at. So if a substance has a very low specific heat, it'll change temperature very readily. And most metals have a very low specific heat. That's why you can just drop a hot piece of metal in some water and then it'll just make that little fizzy sound that you heard. And then this right here, yeah, this is holding up quite well. It's probably because this is like stainless steel or something. Now for our aluminium, which I'm actually going to break off a smaller piece so that we can actually put there. This aluminium has a melting point of about 600 degrees Celsius, which is more than the zinc, and that's 3 times more than the pewter, so we're just going to lay that right on there. And all our water that's going to be on there is going to evaporate. So this is going to take way longer, so I'm just going to lay this right here. Alright guys, so update. It still has not liquefied at all, so yeah, I don't know what I'm going to do now, because this is not doing anything I want it to. So, well, in conclusion, we now know that a stovetop does not get to 600 degrees Celsius. I don't know what that is in Fahrenheit. So, what did we learn in this experiment? Well, we learned that zinc, a metal on the periodic table, which should probably come up right now. Okay, and excuse me, I was running to put some tea on the counter. Sorry. Anyway, so, hope you guys enjoyed. We learned... Sorry, wait, why did I... Sorry about that. Anyway, we also learned that a stovetop can melt zinc, which is a metal found in pennies. That is an element, which I just said a moment ago. We also learned that it can melt pewter, which is another type of metal that is not an element. I don't know its chemical composition. Oh, but anyway, I would like to give a shout out to a few people. I would like to thank a few people for inspiring me to get started on a YouTube channel. First, I'd like to thank Jacksepticeye. I'd also like to thank the King of Random and Cody's Lab, all of which you will be able to find a description. A link to their channels in the description below. But anyway, thank you for watching. Ta-ta for now.